Welcome, class. This is our second online lecture. So this is the lecture for the week starting Monday, January. This is going to be boring if I keep going like this. January 28th. Okay, there we go. That's the lecture that we are doing right now. So, in today's lecture, we are going to be learning about motion, and this will lead us into understanding acceleration and falling objects. So I recommend taking notes, so put that in your notes that we're going to be learning about motion. So all of our understanding about motion starts off with very simple types of measurements. So let's give an example. Here's a road, and it's a very boring road. Okay? Here's the road, boring road. Now, again, this is supposed to represent a perfectly straight road. So you'll have to, sorry about that. Here we go, we're running into glitches already. Don't want to learn about, there, okay. There's the center line of the road. So you'll have to use your Platonic imagination to imagine a perfectly straight road, right? And on this perfectly straight road is a car. Here's the car. Bird's eye view of the car. And we can erase the line in the middle of the road, I guess. Here's our car. Oh, did that thing again that we didn't want to do. Okay, there's our car. And the windshield. All right. Now the car is moving in that direction. And we're going to graph the motion of the car over a given period of time. All right? So here we go. This is going to be the distance. And this is going to be time. And I'm having trouble writing because the location that I put my pen on this whiteboard doesn't really correspond to where the image shows up. All right? By the way, for my class that's listening online, there is a live audience here. Say hello to your online brothers and sisters.
Hello, online brothers and sisters.
Okay, so there's a live audience in this class. So this is time. T-I-M-E, time. So now the car isn't moving at a constant velocity. So if we graph what happens as the car drives, you'll see some changes. So let's say in 10 seconds, so here's 10 seconds, it goes 10 meters. So, Andre, if it goes 10 meters in 10 seconds, how fast is the car going?
1 meter per second.
Very good. Great, great. Then, let's say in the next 20 seconds, so that would bring us to 30 seconds here. And I'm sorry, I know this is kind of hard to see as a screen. It's just the nature of this screen. I'll try to adjust it. The next segment of the graph, say it goes at this point it's at 100 meters, for example. I know this is not really great quality. Try to move that mouse out of the way. So, Nicholas, in this 20-second period from here to here, how far did the car go? Good. 90 meters. Right. So in the first segment, the blue segment, so in the first segment, 1, it went 10 meters in 10 seconds. In the second segment, 2, what did you say? How much did it go? Right, it went 90 meters in how many seconds? Oh, sorry guys. We're going to have to adjust this thing. It's nuts. What, you said 90 meters? Oh, I can write on it with my finger. That's kind of fun. Let's try it. Wait, 90 meters in 20 seconds. Okay. So obviously the velocity is faster in the second part of the graph, right? And you can calculate the velocity from the graph of the motion of the car. How would we figure out Andre, what did you say the velocity was in the first part? How many? Right, 1 meter per second. So what you do, velocity, new color. So write this equation down, okay? The velocity equals the distance traveled divided by the time the distance was traveled in. And you can see that intuitively if you know that velocity is measured in meters per second. Those are the units. So it's the distance, meters, divided by the time, seconds. Okay, I'm just putting dots there to indicate what I'm talking about, but I think you get the idea. So in the first part, we have 10 meters in 10 seconds, so 1 meter per second. The second part, what do we got, Michael?
Sorry?
How do I figure out the velocity in the second part? Distance divided by time.
Okay.
So
that would be
90 meters, right? Divided by 20 seconds, or 9 halves.
4.
Right, 4.5, and what are the units? Close, meters per, great, very good, 4.5 meters per second. Okay, so you can see that you can get the velocity from a graph of distance versus time. And in the first part, we have 1 meter per second. And in the second part, we have 4.5 meters per second. Now, does anybody in the class know what aspect of the graph corresponds to the number that of the velocity? How would you, looking at the graph, there's a certain quantity you can calculate directly from the graph. Yes. The slope, right? The slope, rise over run, so distance divided by time. Okay, so the slope of the graph gives you velocity. Now watch this. Now I'm sorry again to my online students especially that the writing is so unbelievably messy. I'm going to try to calibrate the screen after this segment is done, and it should be hopefully neater in the next part. Okay, so now I'm going to make another graph right below this. Okay. Oh, I think I can draw perfect shapes with this. We'll have to try that in a minute. Okay, so there's another graph. This is going to be a graph of velocity now. So make sure that the axes correspond when you write this in your notes. They should be lined up just the way I lined that vertical axis up. So this is going to be velocity. And again, time is my x-axis. Okay, so velocity versus time. This is a much simpler graph. I'm going to just drop a dotted line down from where that change happens. What's the velocity in the first part of the graph, Andre?
Well, it's 1 meter per second.
Right. Yeah, so this is what the velocity versus time graph looks like. There's 1 meter per second. Oh, sorry, guys. 1 meter per second. And then it jumps up to 4.5 over here. So it will continue like that. So that's what the velocity versus time graph looks like. See, it's just a sudden instantaneous change. Okay? Okay, good. So this is the first 10-minute segment, and I'm going to try to calibrate things, and we'll continue with the same concepts in the next part.